Welcome back to week 8, Math 99. We were talking about working with polynomials, and we did some simplifying in the last lecture as well as multiplying. Today we want to start with dividing. Now when we're dividing, let's remember what we talked about with fractions. Remember when we were dividing fractions, we kept the first fraction the same. We changed dividing to multiplying, and then we found the reciprocal of the second fraction. So the first fraction is the same. Dividing changes to multiplying. We found the reciprocal of the second fraction. And now we just have a multiplication question. And we said in the last lecture, remembering what we did with fractions, that you just multiply numerator times numerator, denominator times denominator. And of course, we said the denominator cannot equal 0. Oops, didn't want that to happen. There we go. So we see that B cannot equal 0, C cannot equal 0. But if you look carefully at this question, what do you notice? You notice that at the start of the question, D was also in the denominator. So D cannot equal 0 either. So when we're looking for restrictions in the division of rational expressions, we need to be careful. We need to check B, C, and D. So the steps you'll notice are almost the same as the steps I gave you for multiplying rational expressions, but we have step 1. First, you want to change it to multiplication by the reciprocal. Then you want to factor. One of the biggest mistakes I see on tests and final exams is that people don't factor everything. Make sure you factor every numerator, every denominator. Then we divide out common factors. Remember, we're looking for common factors, parts that are multiplying, and we're factoring from the top and bottom, not side to side. Finally, we multiply, and because we want practice, we're going to find restrictions. So here's our first question. Step 1, change it to multiplication by the reciprocal. That means our first expression stays the same. Dividing changes to multiplication. Find the reciprocal of the second expression. Now we factor everything. You should pause your video and factor this yourselves. Did you get all those factors? Now we can divide out common factors. X minus 3 is a common factor. X minus 2 is a common factor. And notice, let me change that color there. 7 is positive, 7 is negative, x is negative, x is positive. These are opposite factors. When we divide out opposite factors, it always equals -1. So we're left with -1 times x plus 2. The denominator has no factors left. That means this could all be written over 1, but we're finished here. We do want practice looking for restrictions. If you didn't find your restrictions already, pause the video and do so now. Remember that for restrictions, we're looking at B, C, and D. So if I look at my first factor here, 7 minus x cannot equal 0. X cannot equal 7. Here, x cannot equal 3. Here, x cannot equal 2. If I use this one, it's going to give me the same restriction as this factor, x cannot equal 7, and I've already used x minus 2. So we had 3 restrictions for this question. I've left you some space here on the side for any rough work, any factoring you need to do, because remember, I don't need to see the work for your factoring here. I just want to see the factored expression. All of that work should be on rough paper. So pause your video, see if you can do this question. So step 1, change this to multiplication by the reciprocal. The first expression stays the same. Dividing changes to multiplication. Find the reciprocal of the second expression. Now you want to factor everything. I wanted to point out the way I'm formatting the questions. Notice that the equal signs are all lining up down the side here. Notice that my question is written on top of each other in a nice column. This is the correct way to present a math solution. And especially for those of you planning on heading into Math 103, into calculus, it's important to know how to write your questions. So use the examples I've given you every week to show your work correctly. Now that we've factored, we want to cross off, divide out common factors. X minus 7 is common. 2x plus 1 is common. X plus 3 is common. We're left in the numerator with x plus 7 all over 4x. If you haven't stated your restrictions yet, pause the video and do so now. Remember, for the restrictions, we're looking at B, C, and D. So let's start with 4x. X cannot equal 0. X cannot equal -1/2. X cannot equal 7. X cannot equal -3. I've already used the factor 2x plus 1. I've already used the factor x plus 3. We have 4 restrictions for this question. Another one for you. Pause your video, give this a try. So first of all, we change this to multiplication by the reciprocal. The first expression stays the same. Dividing changes to multiplication. Flip over or find the reciprocal of the second expression. And now you need to factor everything. Now we can divide out our common factors. We see that x plus 2y is common. X plus y is common. Did I make a mistake? I feel like I did. Yes. This is supposed to be x plus y here. But we also have 3 common. Divide by 3, divide by 3. So in the numerator, we're left with x plus y. In the denominator, 2 times x minus y. If you're asked to leave your answer in factored form, this is where you would stop. If you're not asked to leave it in factored form, you would have to open the brackets in the denominator. Both of those are fine. If you haven't already found the restrictions, you could pause your video. Remember, we're looking at B, C, and D. So let's start with this factor. X plus y cannot equal 0. Well, this tells me that x cannot equal negative y. X minus y cannot equal 0. X cannot equal y. If they're the same number, it would be 0. There's no x here in this factor of 6. 6 will never equal 0. X plus 2y cannot equal 0. X cannot equal negative 2y. And we have already used this factor of x plus y. So we have these 3 restrictions of x as it relates to y. One more for you to practice. Pause your video, see what you can do. So we changed this to multiplication by the reciprocal and then factored every part of the question. We see that 2x plus 1 is a common factor. 2x minus 1 is a common factor. In the numerator, we have x plus 3 times x minus 1. In the denominator, 4 times x plus 2. This would be your answer in factored form. If you are not asked for factored form, you need to open the brackets. And you needed to state your restrictions. Remember, you're looking at B, C, and D. So we have 2x minus 1 as a factor that cannot equal 0. X cannot equal 1/2. X cannot equal negative 2. There's no x here. I don't have to use that factor. 2x plus 1 cannot equal 0. X cannot equal negative 1/2. We've already used 2x minus 1, but we also have this x minus 1. You should have 4 restrictions for this question. And one more. If you haven't already done so, pause your video, give this one a try. So again, you've changed this to multiplication by the reciprocal and then factored everything. We have common factors of 3x plus 2, x minus 2. Is that out? Looks like that's it. So we're left with 2x minus 1 times x plus 3 all over 2x minus 3 times x plus 2. This is your answer in factored form. If factored form is not asked for, you're going to need to open the brackets. And again, I don't want to see your multiplying work. All of the work that you have for multiplying out those binomials should be done in your rough workspace. If you haven't found your restrictions yet, pause the video and do so now. Again, for division, we're looking at B, C, and D. There are a lot of restrictions for this question. Did you have 6 restrictions? Hope so. So now we want to talk about adding and subtracting with rational expressions. We're going to start with some easy questions, not the kind of questions I'm going to give you on your test or exam, but a good place to start. Remember when we were adding and subtracting with fractions, we said if the denominators are the same, you keep the denominator and then add or subtract the numerators. Of course, the denominator cannot equal 0, but we remember that we need a common denominator. The denominators need to be the same. So if we look at question 1 here in this example, the denominators are the same. That means we can keep the denominator and add the numerators. Combining like terms, we have 4x plus 1 all over 2x. There's nothing to simplify here, but I know that x cannot equal 0 because 2 times 0 would give me 0. Let's look at question 2. Oops. In question 2, we are subtracting, and we have a binomial here. That means we're subtracting all of the second expression. We still have common denominators. So we're going to keep the denominator. And we're going to subtract all of the second expression. Remember, when we were subtracting polynomials, that meant we have minus 2x minus 9 all over our common denominator. So this gives me x minus 4 all over x squared minus 2x minus 8. I know I can factor that denominator. I'm going to see if I can give myself a bit more room here. There we go. Oops. So let's factor that. Now we see that x minus 4 is common. Remember, we said that you should always simplify your rational expressions. In the numerator, we have 1. In the denominator, x plus 2. This is our final answer for this question. But what about restrictions? Well, we need to look at our denominator in factored form. We see that x cannot equal negative 2 because negative 2 plus 2 would be 0. We see that x cannot equal 4 because 4 minus 4 would give us 0. The next two both have common denominators. Why don't you see if you can do those? I'm just going to move this back up so I have enough room to work. All right, common denominator. Keep the denominator. I notice that I'm subtracting, so I have to subtract all of that. You don't have to necessarily write that step, as long as your numerator says 4x minus 7 minus 2x plus 8. Combine like terms. I'm going to factor that denominator to see if I can simplify any further. Yeah, I can divide out that 2x plus 1. And what about our restrictions? Remember, we're looking at the denominator. Excuse me, we're looking at the denominator. The denominator cannot equal 0. If you haven't finished question 4, pause the video and give it a try. Again, we are subtracting. So you have 2 minus 7x plus 10x minus 3. I know I'm going to need to factor the denominator, and we did it in the last question. So for the numerator, 10x minus 7x is 3x. 2 minus 3 is negative 1. All over 2x plus 1 over x minus 3. There are no common factors to divide out. So if you're asked for factored form, you would leave it there. If you're not asked for factored form, you would have to multiply out those brackets. What about your restrictions here? Again, we're looking at that denominator, only the denominator. We see that x cannot equal negative 1/2 or 3. It's the same restrictions from question 3 because the denominator is the same. But like I said, those were the easy questions. Before we move on to more difficult questions, let's talk about finding the lowest common multiple of polynomials. Before we look at polynomials, let's look at numbers. No, let's say 20. Remember back when we were working with numbers, and if you've forgotten, you should go back and practice. We always ask these questions on your final exam. We said you should prime factor. And then we said that the lowest common multiple of 12 had to contain 12. 12 is 2 squared times 3. The multiples of 20 had to contain 20. 20 needs 2 squared. We already have it. 20 needs a 5. We don't have a 5. So 4 times 5 is 20 times 3 is 60. There's our lowest common multiple. Remember, we were using all of the factors to their highest exponent. Let's do 2 examples together. You'll notice in the first 2 examples, I've got factors for you. Polynomial 1 needs the factors of x minus 3 and x plus 7. Polynomial 2 needs x minus 3. We've already got it. But it also needs the factors of 2 and x. This is the lowest common multiple. In the next example, polynomial 1 needs 2 factors of x minus 1. Polynomial 2 needs x minus 1. We've already got x minus 1. But it also needs a factor of x plus 1. This is the lowest common multiple. Notice that you need to factor first. So why don't you pause the video, factor these 2 polynomials, and find their lowest common multiple. So our first polynomial needs the factors of 5 times x plus 3. Our second polynomial needs x plus 3. We already have it. It also needs x squared. Well, we usually write that as 5 times x squared. There's our lowest common multiple. See if you can do the next two. All right, in this one, I need the factors of x plus 7 and x minus 7. I need an x plus 7, we already have it, but we also need x plus 3. This is our lowest common multiple. I need two factors of x plus 4. I need x minus 8, don't have it here. And I need x plus 5. This is our lowest common multiple. Now, one of the things you need to be able to do as we move forward to looking at adding and subtracting is to determine what's missing from each polynomial. So let's go back to that first example. If I'm looking at this polynomial and comparing it to the lowest common multiple, can you see the missing factor or factors? It's missing 2x. What about the second polynomial? What is it missing? It's missing the factor x plus 7. What's missing here? It's missing the factor of x plus 1. What about here? There's only one factor of x minus 1. We have 2 here. It's missing a factor of x minus 1. See if you can find the missing factors for the rest of these polynomials. Excuse me. Okay. Let's go on and start adding and subtracting. Oh, no, we're not. I guess I'm saving that for next week. Okay, so where's all the questions here? There they are. There's some practice here for you, multiplying and dividing. There's some practice adding and subtracting. These all have common denominators. So next week, we will look at adding and subtracting without common denominators. Make sure you know how to find a lowest common multiple. The solutions for all of these questions will be found on your class Moodle page.